Hi, in this video I will be making a favorite old project of mine. It's a line follower robot. It's a really fun to make beginner robot and it's a great way to get started with robotics. And in today's video, I will show you the details of how I made it. So without further ado, let's get started. As with most of my projects, I started by drawing. And in this case, I used Fusion 360 to draw a simple 3D design of my robot. This gave me a good idea of how I should proceed with the build. For this project, we're going to need the following parts. As you see, I got an Arduino Nano, a QTR8A sensor array, an L298 motor driver, a voltage boost converter, a gearbox and a wheel set, and a few other parts. You can find links to all the parts in the description down below. The chassis is one of the most important part of the project. I decided to make my own chassis for this robot. Now you can of course buy chassis from online for pretty cheap, but hey, it's more fun to make, right? I started by roughly cutting two round shapes with 18mm diameter from some 4mm plywoods. I used some bolt and nut to connect the roughly cut shapes to a drill in order to sand it down to the final shape. The shape came out to be really round and smooth. Then I cut some holes for the wheels and put the gearbox together. Once I was done, I took the bottom and top plates together and drilled some holes for the bolts that will hold them together later on. I tested the bolt and nuts and the shape was really strong. Then I started populating the bottom board with the QTR sensor array, the ball caster, the voltage booster board, and the battery. The voltage booster will keep the voltage stable at 9 volts so that the motors go at the same speed no matter what the battery voltage is. This will later help us to tune the PID values easily. If you want to paint the robot, make sure to do it before you put everything together. And note that the sensor array should be really close to the ground for it to work optimally. I went with a height of only 3mm. The sensor array is a series of infrared LEDs and receivers. The LEDs emit invisible infrared lights and wait for it to be reflected back to the receiver. If the reflection surface is white, most of the light is reflected back and we read a low value on the sensor output. But if the surface is black on the other hand, we get a high value on the Arduino. Next, I soldered some wires from the battery to the boost converter. I kept the positive wire long so that we can cut it later and add a switch. I also soldered some wires to the motors and twisted them together. The reason we twist the wires together is to get rid of any noise from the motor that might affect our sensor readings later. You can also solder a small ceramic capacitor to get rid of motor noise. Then I attached the top plate and put the motor driver, breadboard, and switch on top. I had to add an additional piece of wood to make sure the switch was not hitting the wheel. Then I started wiring everything together according to this schematic. I made some cables to connect the sensors to the breadboard. You can just buy some male to female jumpers instead if you want to. I additionally added an ESP32 module with a display called the M5Stick-C. I'll talk more about that later. So our robot is ready to be programmed. And this was actually the hardest part for me. First, I made a track with some black electrical tape on a large white platform to test the robot. For this robot, I wanted to use a PID controller in the Arduino code. What it essentially does is that it takes the sensor values as input and checks where the black line is. If the line is in the middle of the robot, it makes the motors go at full speed. However, if the line is a bit to the side, it outputs a positive or negative value to make one of the motors go faster or slower so that the robot turns and comes back on the line. The PID controller is basically doing the same thing you do when driving a car on the highway. I watched many line follower robot articles and codes to get an idea of how I wanted my code to be. And then I started writing the code for the project. In a PID controller, there are three constants: the proportional, the integral, and the derivative. These values define how the robot will act at different positions of the line under the sensor. You have to tune these values for your robot to make it follow the line efficiently and accurately. And that is where the problem started. I couldn't find a decent value that worked well for the robot. It would follow the line's fine at slow speed, but at the higher speed, it would lose track of the line. After almost 1 day of tuning, it was finally following the line at 60% speed. Thus, the robot was finally complete. I'm really happy with the results, and I think it's pretty fast for the small motors that we used. And I also added an M5 stick module. It is an ESP32 module with a display on it. Having the display means that I can print different values and check if there's a problem. It is communicating with the Arduino Nano through serial communication. It also has Bluetooth built in, so I also added a telemetry system with the Bluetooth. I can set the speed, the P, I, and D values through my phone. I can also check the input and output values of the PID controller to make sure everything is working properly. So I hope this video inspired you to make something similar. If you liked the video, don't forget to like, share, and subscribe to my channel. Keep making, and thanks for watching.